Now we are going to take the next topic, electrostatic force due to continuous charge distribution. What is the meaning of continuous charge distribution? It means distribution of the charges are closely spaced. You have to make sure what does it mean. Here, charge is not continuous. It is not continuous. This charge is not continuous. Then what is there? The charge distribution, it means the charge is discrete, but it is closely spaced. Means charges are such placed that the distance, the gap between the two charges is too small, and that distribution gives a appearance that it is making, like if it is in one dimensional, it is making a line. So this point is must be clear. What is the meaning of the continuous charge distribution? It is of three types. The first one is the linear charge distribution. In the linear charge distribution, the charges are closely spaced and they are forming a line. In a line, they are so. The other is the surface charge distribution. Here, charge distribution is such that the charge particles, they are placed in a plane. So it is two dimensional. The other is the volume charge distribution, in which the charges are closely spaced within a space. So it is three dimensional. Here we take the positive sign. It is a bit conventional. It can be done with the negative charges too. Now we are going to find out the electrostatic force due to linear charge distribution. We have considered an arrangement of linear charge distribution in which a small element of length dl and having charge dq is taken. Let q not be any other charge, and we are going to find out how much electrostatic force is experienced by q naught due to this linear charge distribution. To find it out, we have applied the Coulomb's law. First, we have taken the force between dq and q naught. That is given by, because the element is very small, the force is given by a small element df, that is equal to 1 by 4 pi epsilon naught q naught dq over r square. One more factor I want to introduce here, that is linear charge density. It is denoted by lambda. It is given by lambda. It is equal to q by L. This is charge per unit length. If we are taking a small charge of length dl, that will be equal to dq by dl. So if we are going to take dq, that is equal to lambda dl. Now we will replace dq by linear charge density into dl in above equation, and we will get the force equal to 1 by 4 pi epsilon naught q naught lambda dl by r square, where r is the distance between the small element and q naught. To find out the total force for this whole charge distribution, we will integrate equation number 1 over the entire length, say L. So, integrating equation number 4, we will get the total force experienced by Q naught because of this linear charge distribution, and it is given by the equation F is equal to 1 by 4 pi epsilon naught Q naught and integration of lambda dl over r square for the entire length L. The next we are going to find out the unit and dimensions of linear charge density lambda. This is a very common short answer question. So to find out the units, we'll take the formula. Q lambda is equal to Q by L. The units of charge coulomb and of length is meter. So unit of lambda is coulomb per meter. Next is to find out the dimensions. We will take the formula lambda. The dimensions of Q is equal to 80 and of length is L. So dimensions of lambda is M0, L minus 1, T1, A1. So this is the dimension formula for linear charge density lambda. Now we are going to take the next topic. It is surface charge distribution, in which we will find out the force because of this surface charge distribution and this test charge Q naught. For this, what we have done, we have taken a very small area element, that is ds. It is having the charge dq. So first we will find out the force between this small charge dq and q naught. For that, we have taken the help of Coulomb's law, and according to that, the force between dq and q naught is given by df is the small force existing between them. It is equal to 1 by 4 pi epsilon naught q naught into dq by r square. Here, one important term I'm going to introduce is surface charge density. It is denoted by sigma. Sigma is equal to charge over area. This term is charge over area. So this is equal to dq over ds, and from here we get dq is equal to sigma ds. So this value of dq we can put over here, and the equation will become df is equal to 1 by 4 pi epsilon naught q naught sigma ds by r square. Now, to find out the total force experienced by Q naught due to whole surface, we will integrate the equation number 1 with respect to the surface S. So, we will get the total force F is equal to Q naught 4 pi epsilon naught integration over sigma over S for sigma ds by r square. In the next step, we are going to find out the units and dimensions of surface charge density sigma. It is equal to sigma is equal to charge over area. So units of the charges are coulomb and area is meter square. So the units of sigma comes out coulomb meter inverse square, and the dimensions of sigma, that is given by charge dimension is given by 80, area is given by L square. So M is not there, M0, L minus 2, T1, A1. So these are the dimensions of sigma. Now we are going to find out the volume charge distribution and the force because of that on charge Q naught. We will take a very small element, volume element dV having the charge dq. This is the small volume element dV. Now, according to the Coulomb's law, the force existing between q naught and dq is given by df, the small force, 1 by 4 pi epsilon naught q naught dq by r square. Now, one volume charge density is a term that is introduced here. This is denoted by rho. It is equal to charge over volume. It is equal to dq by dv. So dq comes out to be rho dv. Using this value of dq in this equation, we will get the equation small force df equal to q naught 4 pi epsilon naught rho dv by r square. Now we want to find out how much the force is experienced by Q naught due to this entire volume. For that, we will integrate the equation number 1. Integrating it over the entire volume, we will get the total force experienced by Q naught due to the volume charge distribution V, that is Q naught by 4 pi epsilon naught. So integration over the entire volume V of rho dV by r square. We are going to find out the units and dimensions of volume charge density rho. Since the formula for this charge density, volume charge density is charge upon volume, and the units of charge are coulomb and volume is meter cube. So units of rho become coulomb meter cube inverse. And about the dimensions of rho, charge is having the dimensions 80 and the volume is having L3. So the dimensions of rho comes out to be m naught, there is no mass, L minus 3 T1 A1.